Hi, thank you, Esther. Well, as Esther said, I am going to talk about the future of energy markets and the transition to decarbonization. So, yes, well, here we are going to talk about the transition of future energy markets towards decarbonization. And to do so, here we can see a brief summary of what are we going to talk about in this presentation. Well, first of all, we will discuss a little bit why do we need to change? Why do we need, in fact, this transition? And then once we have a little bit clear why do we need to change, we are going to talk about, well, how do we have to change? And in this section, I will try to focus a little bit on the role critical to this energy transition, and then we will talk about how can we transform this consumption and what are the techniques and tools required. And at the end, we will perform a little bit of conclusions about the contents of this presentation. So let's start with why do we need to change? Well, as we all know, climate change is a critical issue with worldwide implications whose effects have to be stopped or slowed down as much as possible to avoid further consequences on the environment. This issue, which has raised attention all around the globe, has led to the assignment in 2016 of the Paris Agreement, in which countries compromised to keep the increasing global average temperatures below 2 degrees Celsius. However, the current economic model for most of the countries in the world is the economic growth. And this economic growth until now has directly led to an increase in the energy use and an increase in emissions. But it is true that we can, in fact, achieve a more secure and sustainable energy system without sacrificing economic growth through decarbonization. If we decarbonize our energy market, we can achieve an energy system with no emissions and more independent from the external energy markets, and which will allow countries to continue growing without harming the environment. To perform this decarbonization, it is critical to make a change in the market, not only on the structure, but also on the roles that the stakeholders and the end users have in the current energy market. So we have seen that there is indeed a need to change, and we have to ask ourselves now, but how do we have to change? The first of them is to do a transition from high operational costs that are linked to traditional energy sources to low operational costs but high capital expenditure. So to allow our energy sources that have these low operational costs but high capital expenditure characteristics to be included in the market and to be profitable, we have to adapt the market pricing structure, which is present nowadays, to make it interesting for investors to invest in these technologies. Another thing that will happen in this path to a transition is the electrification of the system. There are some systems that are hard to decarbonize, and this electrification will help them, sectors such as heating and transport, because they can employ electricity that comes from renewable energy sources to not perform emissions. However, this all seems very beautiful, but renewable energy sources do have problems. These problems is that they are intermittent and non-programmable, and they create a challenge for their inclusion, because until now, with the traditional market structure, what we are doing is that we are generating energy as we are consuming it. It means that we generate according to the demand. But within our energy sources, we cannot do this because we cannot control the regeneration. So we have to perform a change. So to completely decarbonize the market, there are two widely accepted options. One of the options or scenarios, one of the options is to keep our energy sources at a level which is technically achievable or technically possible with nowadays energy market structure. So we are still kind of thinking about what these consequences will be in the long term. And the other thing about these scenarios is that to employ carbon capture and storage techniques, we still need a large-scale validation that has not been performed until now, and a CO2 infrastructure to transport these gases have to be developed, which nowadays does not currently exist. So there's another option, that is to, instead of employing these conventional nuclear power technologies at an important weight in the market, we can increase the renewable energy sources share at aiming to fulfill as much as demand as possible with them. But to do so, we have to change and to flexibilize the demand to be able to consume the energy that's being generated by the renewable energy sources at the time when this is generated. This flexibility that has to be implemented will change drastically the market structure, switching it from a centralized structure to an hybrid and decentralized structure, which has to account with energy storage installations and has to deploy smart energy grids, distributed energy resources, and consumers should adopt smart energy management strategies. Well, keeping in mind a little bit all the pros and cons of all these scenarios, it is probable that in the future we will have an energy market, or in the close future, mostly centered in the second option, although it is true that the first option, the technologies of the first option, will still be required to feed the energy that is generated by renewable energy sources. So we have seen here that consumers will play a key role in the future energy market because they are the most important actors, or an important actor, maybe not the most. So now that we have acknowledged the role of the consumers, we will talk a little bit about the transformation of the consumers, and I will focus especially in the industrial case, which is the one that we are working nowadays. So why the industrial case? Well, industries often present a multi-carrier energy system with several energy transformer equipment, and also the possibility to include renewable energy sources and electrochemical storage systems or thermal storage systems, presented in a single entity in front of the market able to exchange energy with it, being a virtual power plant or a power summer. So here we can see a little bit what could be the infrastructure of this energy industry. We can see here a set of transformer equipment and also renewable energy sources and electrochemical storage. The important thing in terms of energy transition in this infrastructure is that it has a bidirectional connection with the utility grid, meaning that it can buy and sell electricity depending of the price of the energy at the electricity market. And how does this support decarbonization? Well, as we have said previously, the costs of the electricity at the wholesale market is lower when there is renewable energy sources because they have an operational cost lower. We are using this electricity from renewable energy sources, and if we are selling electricity when the cost at the wholesale market is high, what we are doing is inserting our own electricity into the market when the market is requiring more electricity and is employing more contaminant technologies to be able to fulfill these peak demands. Well, so in this way, we can support the transition to decarbonization and support the insertion of renewable energy sources by this flexibility. But we have to adopt this smart energy management strategies. We need a framework, a technological framework that will enable industries to be able to plan and optimize these transactions to be able to obtain as maximum profit as possible. To do so, the first thing to do is that we have to model the energy assets in the industry. Then we have to forecast the energy vector, the future energy vector, including demand and electricity price. And then we have to optimize the operational set point to be able to evaluate the different energy flow alternatives, obtaining a high reliability of supply. Here we can see a block of diagrams with a case industry that we have developed. And in the right hand of the presentation of the slide, we can see the generic matrix form of the energy hub and the one applied to the one that we are studying here that relates the demand with the generation through a connectivity matrix, which is based on the efficiencies of the equipment and the dispatch factors. Once we have obtained this energy hub model, what we have to do is to forecast the future energy scenario, because they are able to deal with nonlinear characteristics and the different patterns of this type of parameters. Here we can see in the diagram where we have employed AMFIS, that is an artificial neural network. What we can see here in this diagram is the forecast of the electrical demand. In this case, it doesn't appear here, but the mean absolute percentage error is of 5%. That is a really, really nice value for this type of predictions. And then once we have the energy model, we have done it through genetic algorithm. That is a machine learning tool that enables to consider all the search space of the solution and avoids falling in a local minimum and enables to obtain the global minimum. Here we can see the result. In the left diagram, we can see the purchase of energy, and in the right one, the selling of energy. The first thing that we can see here is that, in fact, we are not purchasing electricity when the electricity at the price of electricity at the wholesale market is high. And another interesting thing here is that we are purchasing gas at a higher rate than needed most of the times. Why? Well, gas is cheaper than electricity in most of the energy markets in Europe. Here in this case, we have used, I haven't said, the electricity parameters of the OMI market. If there's surplus energy, to store it in the energy storage system to be able to sell it at the times where the electricity at the wholesale market is higher. So here, what we can see is that we are trying of synchronizing both thermal and electrical sides of the factory to be able to exchange in an optimal manner the energy with the utility grid. We can see that there has not been only where we can achieve this active energy exchange and injection of green energy into the grid by controlling and by this methodology we have presented. And this is not only useful for the energy market, but it is also economically viable for the enterprise itself, making it an attractive option for investors. So the first thing that we have seen in this presentation is that there is indeed a need to perform the transitions to a more secure and sustainable energy system. For this transition to happen, renewable energy sources and flexibility are required. And for this flexibility to be created, consumers have to change their behavior and adopt smart energy management strategies. As consumers cannot be all the time looking at the price of electricity and how can it be optimal to trade energy, artificial intelligence and machine learning are key tools for the successful decarbonization and for the participation of the different entities in the consumption side into the electricity market. So this has been all from my side. I hope you have enjoyed this presentation. And now if you have any questions, please feel free to ask.
Oh, thank you, Eva, for this very interesting talk. Unfortunately, there were some gaps from my side, so I was wondering, maybe you had some very interesting figures on slide 13. Maybe could you go back there? Yes, exactly. So I was wondering if you could just very quickly point out again what we can see there on the right side. And then I will, of course, check if there will be more questions. Yes?
Okay, this is just, yes, we are here seeing the purchase and the sale of electricity to not purchasing electricity when the price is higher and instead selling it. We are selling electricity generated that from the renewable energy source. In this case, it's a photovoltaic system. And in that time, we still have internal demand. What in the previous time, we have been saving electricity from points where the cost of electricity was lower. We are inserting it into an electrochemical storage also with the support of the cogeneration system to be able to sell electricity when this cost is higher, and thus avoiding the use of this expensive energy from the utility grid.
Great, thank you. I think we have maybe time for one quick question. Do you have any ideas or plan how we could balance the centralized versus decentralized energy storage with production as well? Like, you know, this, yeah.
No, please go ahead.
I just wanted to make it more clear, like there are these decentralized energy networks coming more and more, at least in Switzerland. I don't know how it is in Spain or in other countries, but do you have any idea on how we could balance these new developments in the energy network?
Well, I think that a key issue in this case is that we have to be able to forecast correctly the energy demand and the price that the energy that is being generated. Okay, no, I'm just saying that we have to be sure what are the rules of this energy exchange, what are the consumers that are working with these energy storage systems and the energy that's being generated, to be able to create this smart grid, to model it properly, and to forecast the operation of this in a I think that a weekly horizon is suitable to be able to properly work it and obtain as maximum profit as possible in terms of the use of these batteries and the employment of renewable energy sources.
Great, thank you. And then there are now questions in Socio also, one from Braulio Barahona. He says, thank you very much for the nice presentation. And what do you think, how far ahead is the forecast prior to the optimization of the equipment set points?
Well, the forecast, in fact, the forecast works pretty well. We have been working with these forecast techniques and it provides important results. And the optimization, it also provides a good balance between this, but it is true that we have, well, this study, we are trying to implement it in a real industry, but we have been finding legislation gaps because we are still a little bit far away from this to happen. You know, we are, well, at least here in Spain, we are not that advanced. So we are still a little bit finding administrative gaps that we have to fulfill.
He says, what percentage would be of CO2 that we can saving with using such an algorithm?
Well, in fact, you can set this percentage of saving because this type of algorithm has the possibility to include the maximum CO2 that you want to emit with your enterprise. In fact, only by inserting this type of methodology, you are already saving CO2 but in your own enterprise, not only in the wholesale market. But it is different to measure the one that you're saving in the wholesale market, but you can put restrictions on your own CO2. So you can set that in your operation, you want to restrict your CO2 emissions up to what point. That is what enterprises are looking for, to be able to, in 10 years or 25 years, you reach the neutrality.